Hello and welcome to Online Learning with Stephanie. Remember, maths is beautiful. In this second video, we're going to look at the main ideas behind a base number system. Now, when we look at a number, every symbol has a place and a value. We can put the number in a place value table to see this. For example, this is a place value table for a tens number system, a base 10 number system. And each place value is a power of 10. So we have the ones in the first place, then we have tens, we have hundreds, and we have thousands. And you can see that each one of these is a power of 10. And what I mean by that is shown here. The first column, the ones, is the same as saying 10 to the power of 0, which is 1. The second column, the tens, is the same as saying 10 to the power of 1, which is 10. The third one, the hundreds, is the same as saying 10 to the power of 2, or 10 by 10, which is equal to 100. And the last column we have here, the thousands, is the same as saying 10 to the power of 3, which is 10 multiplied by 10 multiplied by 10, or equals 1,000. That's how we get the place value for the base 10 number system. And following this pattern, we know that the very next power on this chart would be 10 to the power of 4, which is 10 multiplied by 10 multiplied by 10 multiplied by 10, and that's equal to 10,000. So if we were to extend this chart one more place, we would have ones, tens, hundreds, thousands, and then 10,000s. And this continues on depending on how large our numbers are. When we put a number in the place value table, we can see that each part of the number represents a different value. In the number 4,032, we can see that the number is made up of 4 thousands, 0 hundreds, 3 tens, and 2 ones. Or we could write it like this. 4 times thousands, 0 times hundreds, 3 times tens, and 2 times the ones. Putting this together, we have 4,000 plus 0 plus 30 plus 2. 4,032. That's how our number system is worked up. Place values and the amount within that place value. Looking at a different number, if we had 1,256, we can see that this number has 6 ones, 5 tens, 2 hundreds, and 1,000. Writing it, it would be 1,000 plus 2 hundreds plus 5 tens plus 6 ones. 1,256 is our number there. Now, what if we wanted to add another 5 to this number here? We know from mathematics that we could just add it like this. 1,256 plus 5. 6 plus 5 is 11. Write down the 1 and carry 10. 5 plus 1 is 6, 2, and 1. Our new number would be 1,261. But what's actually happening in the place value table here? Now what happens is that we see this 6 and we need to add 5 to it. We know that 6 plus 5 is equal to 11. But we can't have an 11 in this place value table because, going back to our previous video, we know that the highest symbol we can write is a 9 in each of these place values. So 11 is not going to work. But we know that the next place value over is tens. So what we do is we take this 11 and we subtract 10 from it and we move 10 into this place value. Okay, 11 take away 10 leaves us with 1. So we write the 1 in here. Now we've already got 5 tens and we're moving one group of 10 in here. So 5 tens plus another group of 10 is equal to 6 tens. And then we've got 200s and 1,000. And so there's our number, 1,261, which is the same number we got there. But this just shows you that when we have too many numbers in one place value, for example, it's gone over 10, we have to borrow 10 from that number and move it into the next place value and write the remainder here. 11 minus 10 is 1, so we write the remainder there, 1. And we had 5 tens to begin with, and we've added an extra 10, and that makes 6 tens. Now, what if we actually wanted to add something to a different place value? Just say we wanted to add another 6 tens or 60 here. Well, it works the same way. We know that 5 plus 6 is equal to 11 again. Now we can't write 11 in this place value because we can only go up to a 9. So again, we're going to have to take this 11 and take away 10 from them. 11 take away 10 is 1, and we write that remainder here, 1. And these 10 then have to go into the next place value, which is the hundreds. We already have 2 lots of 100, and we're adding another lot of 100 there. 2 plus an extra group of 100 is 3. We haven't done anything to this one, and we haven't done anything to this one. So our new number is 1,316. And this is when we've added plus 60 or 6 tens to the number. The really important thing to remember is that even though we're taking 10, because it is a base 10 system, a 10 represents one group of something. So even though we're taking 10 from this 11, as soon as it moves over, it represents one group. We already have 2 groups of 100, so adding over one more group is how we get the 3. We're not adding 10, so it becomes 12. 2 plus 10 is 12. No, the 10 moving over becomes one group of 100. 2 groups of 100 plus one more group of 100 equals 3 groups of 100. So far we've looked at a base 10 system and the place value table for that, but we can use this table and this idea for any of the number systems that we're going to be working with. We're now going to look at the place value table for a base 5 number system. You will see, like the last one we've looked at, we are looking at 4 place values, but the numbers up the top look a little bit different. In a base 10 number system, the first value was ones and then tens, hundreds and thousands. But in a base 5 number system, we start with ones, then we have 5s, 25s, and then 125s. Now this may seem a little bit strange until we have a look a little bit closer at the powers of 5, because we're dealing with a base 5 number system. Alright, have a look at this table here. Our first place value is 1 because 5 to the power of 0 is equal to 1. Our second place value is 5 because 5 to the power of 1 is equal to 5. Our third one becomes 25 because 5 to the power of 2, or 5 multiplied by 5, is equal to 25. And our last one is 125 because that is 5 to the power of 3, or 5 multiplied by 5 multiplied by 5. And this is exactly the same system that we had with the base 10 number system. We have a base of 10 versus a base of 5, but we still have a power of 0, a power of 1, a power of 2, a power of 3, and that continues then power of 4, power of 5. With our base 5 system, we have 5 to the power of 0, 5 to the power of 1, 5 to the power of 2, 5 to the power of 3. And we could continue this on thinking that our next place value here would be 5, base 5 to the power of 4, or 625. But we will just leave it for the 4 at the moment. So you can see that the number systems for place value works in exactly the same way, just the numbers have changed. We take our base number, either base 10 or base 5, and for each place value we put it to a different power, starting with power of 0, power of 1, power of 2, power of 3. Again, power of 0, power of 1, power of 2, power of 3. This is a base 5 number system. Let's have a quick look at a base 2 number system. Here we have the base 2 number system. Now, already I hope you're starting to think through what this actually means. If we have a look at the table for this one, we can see as follows. The first place value is equal to 2 to the power of 0, which is 1. The second one is 2 to the power of 1, which is 2. Our third place value is 4, which is 2 to the power of 2. And our last one is 8, which is 2 to the power of 3. And we know that if we were to add another column at the end of this one, it would be 2 to the power of 4, which is, 16. Okay, so number systems and place value tables work the same regardless of which base system we're working in. The thing to remember is our base must be whichever system we're working in. In this case, it's a base 2 system. And then we get our place values based on the powers, starting at 0 and working our way through as many as we want, depending on how large the number is. Let's have a closer look at the base 5 number system and how it works to write numbers using a base 5 number system. Now remember that we have two things at work here. We have the actual value of each place in a number, and we have the different symbols that are used to represent those numbers. So imagine that we were writing the number 1, 2, 1, 3. Now keep in mind that these numbers are just symbols. To figure out what the actual number is, we have to remember what these place values are here. So what we're really saying is that we have one lot of 125s, we have two lots of 25s, we have one lot of 5s, and we have three lots of 1s. Okay, so that's 125 plus 50 plus 5 plus 3. So in actual fact, if you were to grab this many beans, say, and you were going to cook and eat this many beans, you would be eating 125 plus 50 is 175, plus 5 is 180, and 3. This is only 183 beans that we're actually talking about. As far as objects go, this number, 183, in a base 5 number system is written as 1213. Okay, remember these are just symbols to represent a number, and our number is 183 in a base 5 system. It looks a little bit different. In a base 10 number system, it would be 183, and that's what we're familiar with. So it's a little bit strange, a little bit hard to get your mind around, but the important thing to remember is that these are just symbols to represent numbers. Depending on the base system you're working in, they're going to look a bit different. The actual number of objects that we might want to eat, beans say, would be 183, but we would write it in a base 5 number system as 1213. Now imagine that we wanted to add 3 to this number, okay? Before we talked about eating 183 beans. We know that if we add 3 to that, our new number would be 186 beans. But this is a base 10 number system answer, and we're looking for base 5. So how would we add 3 to this number? Well, first of all, we do it in pretty much the normal way, and we start with the ones. We say 3 plus 3. So we have 3 plus 3 is equal to 6. Now remember, this is a base 5 number system, and we're only allowed to use these symbols, and 6 is not one of the symbols that we can use. But our next place value is 5, so we're going to take 5 from here and move them into this place value. 6 take away 5 is 1. So we're going to use the remainder and put the 1 in there. Now remember, we're taking a group of 5 over here. We already have one group of 5, and we're going to add another group of 5. So that equals 2 groups of 5. And then we continue on here. So there we have it. We've added 3 to our number. We've gone up from what looks like 13 up to 21, which makes no sense, but it's a base 5 number system, and this is how it works. This number is actually 186, which we can have a look at now when we look at this. Remember that the first column is equal to 1s, so this is 1 times 1. This 2 means 2 lots of 5s, so that's 2 multiplied by 5. This 2 refers to 25. We have 2 lots of 25. And this one lot of 125. So what we now have is 125 plus 2 multiplied by 25 is 50, plus 2 times 5 is 10, plus 1. And we have 186, which is the number of beans that we had before. 183, and we were only adding 3 equals 186. And you can see that this number, 1221, even though it looks strange to us, it actually does refer to the number 186. Okay, I get it. It's a little bit strange, but we're going to have a look at that in a bit more detail in the next lesson. So don't worry about it for now. The important thing to remember is that place value tables all work the same regardless of which number system you're working in. The important thing to remember is that the first place is always 1, and then each one is a power of the base system that you're working in. In a base 5, it's a power of 5. 5 to the 1, 5 to the 2, 5 to the 3, and so on. And we also have to remember that these numbers here are just symbols to represent the actual number that we're talking about. So in a base 5 system, we write the number 183 using these symbols, 1, 2, 1, 3. Yes, that's strange, but that's how it works. And we'll explore that later in another video.